Today we have with us Sebastian Friedl. He's head of the department from FOR GmbH with the Interop4X branch, and he will tell us more about today about the Umati infrastructure. Maybe also important for you is that the recording will be stopped before the Q&A, so also Q&A will not be recorded. And maybe more important is that Sebastian Friedl with FOR GmbH is developing also the Umati infrastructure. So he's really the deep dive expert who is also coding a lot of stuff in the Umati area. And as I know, Sebastian, the presentation was also done by Thomas Dasbach, who is in parental leave. So Sebastian will take care of all the content, but anyway, he will make it pretty good. So Sebastian, stage is yours with the topic using companion specifications for type-based client application.
Yes, thank you, Andreas. Thank you. Yeah, hello also from my side. Good afternoon. And as you told, this was planned to that Thomas and I captured this together or present this together, but Thomas isn't there, and so I need to do this context switch by myself and tell you which part is companion specific and which part is machine specific. To myself, I'm head of Interop4X. We are the branch behind all stuff which is in to the topic of interoperability, OPC-UA. We help companies to implement OPC-UA, consulting them, or have trainings of OPC-UA. Today, we want to introduce you the Umati and the ideas behind this companion specification, why the companion specification are so important on our thing for the interoperability. Telling you something about the Umati, then we will define templates for a client that the clients don't need to do for every system again configuration, and this will cover with this live demonstration. So not only slide puzzle to show you something like live coding in some sketches. First of all, go back to the companion specification. If we start with OPC-UA, and I think this is in the shop floor currently the most use of OPC-UA is that for each application, for each machine device, you have an OPC-UA server and vendor-specific information, what some parameters you got from this. So the IT system can use the same transport layer by OPC-UA, but there is some glue code you need to do to get the information in the same way. And with companion specification, we can solve this problem. And for example, with machinery, every machine has the same identification, has the same machine state, and now there's also the same job management, and that makes the integration in an IT system much more easier. Of course, this will, in the current situation, not plug and play like we know at USB mouses, but the advantage of and the reduced costs there right now, if you do it in the right way. And this is something I want to tell you today, how you should implement such IT system that you can use the companion specification correctly. As Andreas told, we started with Umati, or this is all done in context of Umati. And then I first of all want to go a little bit deeper into Umati and recap what is Umati, what is goals. And for us, Umati is an initiative that aims that machine manufacturers and machine users are close together and work together to get the companion specification interoperability done. For example, the idea behind this is that in a specification there are lots of data points, maybe hundreds of data points you can effort as machine. but the users maybe only use 3, 4, 5 parameters, and this is hard to find out which are the correct parts of the specification or the first parts of the specification you need to implement. And this is something we want to cover in Umati, that we get them, the user and the machine builder together, they talk together and get the specification in the right way, so that everybody has a usage of it. This is done in 3 pillars. First of all, we have the community, where we arrange different events like hackathons, plugfests, organized working groups, user groups, where we can talk together and work together. The next point is the marketing at the right side. Also, we do a lot of marketing and fair participation. For example, there are 14 fairs this year where there is an Umati dedicated booth, so you can get the information on the booth. And today I want more focus on the infrastructure, because this is also part of the dashboard, or the dashboard is part of this, that we have an online data space for connecting machines of different branches, of different vendors, and get the way of this machines in a standardized way, in a uniform way, and we can present it on the dashboard. And this dashboard has 3 goals that should be fulfilled with this. The first is it makes easy to get in first contact with OPSWay, with Companion Specification. You can look, implement your server, get the data on the dashboard, see it's working, and can learn about how it works, learn, make mistakes in a field where nobody cares. And then the second goal is that we provide also the most of the source code or data sources from this infrastructure on GitHub. So you can use this as starting point, have a pre-configured server for machine tools, for robotics, for scales, and you can start with this first prototypes. And the third goal is then that you can also use this on fairs and get their contact with this. Looking deeper on this live demonstration work, Umati live demonstration, if you're on some fairs where Umati is provided, you see such a sticker here on a machine with a QR code, and this QR code can be scanned and then shows the website on this specific machine. Because we are here not on a fair, I want to show you yourself on a website. We have here the Umati website, and go on the start point of this. Here, if we go here to Umati, we get here first overview over the world, see the complete world, also see which machines are online and where are they located. And also you can get the different fairs there that are active. And then you can look at the fair and some machines. For example, I choose here a machine from the machine tools that has here, you see some parameters in a uniform way prepared. For example, here is the tools, the program, monitor information, and so on. And if you look at a similar machine from another companion specification that is working on, you see some of this information, like the identification, are the same. That's because of the machinery. And then we have some new things. For example, here we have the job management based on the OPSWay jobs, and see, okay, we have here one job currently in preparation, which is in waiting. And also maybe here are results, because the job is not started, there are no results. So you see, the there are lots of options. We can only provide text. We can have here badges where we switch the color also from behind. We can make tables. And now we want to do such an integrate a new companion specification on this dashboard. And for this, we choose here the haulage machine type. That's more or less a truck from the mining that is described, which has here some identification. And for example, here also current payload, how much this is loaded. And this is now our target, that we integrate this haulage machine type into our dashboard and then connect an OPSWay server from that implement the specification and start up and see that it's work. To get into this point and get the information on this, we go have first of all a look on the machine itself. Andreas told it, we go deep today. So we connect here for an example server of Umati, where we provide different types of machine, have the entry point of the machines, and this is the complete address-based, the complete information model of the OPSWay server we provide here. And you see we have here, for example, a CNC machine and robots, a scale, and our truck we want to implement. This truck has, as we defined here, our machine equipment identification. Today it's interesting that it has an asset ID with an asset ID. Interesting. Manufacturer ID, serial number, and for other important information. Model is also something we want to show today. And here in our parameter set, we have also here our current payload I showed you before. And if we now look on this value, this should go closer in some after a few seconds. Yeah, now you see the truck will deload it, unload it, drive back, and then we will be uploaded. There is a small simulation of this truck. So to get this done and get this server on our dashboard, we need to do two things. The first is the configuration. This is something we can do here on my computer with our configuration tooling. This is something you do once for each companion specification. So if this is done one time, you can add 1 truck, 10 trucks, 15 trucks from different companion vendors, which all implement the same companion specification. And because we look on this structure from this companion specification, there is no configuration which is done after this. So we have in the second step then the plug and play, where we connect the machine, in our case the truck, to our to our dashboard. This is done via our OPSWay MQTT gateway. So this gateway is started, connect to the OPSWay server, collect the data we need, bring this in our MQTT broker, and then combine this with this template from the template store to our OPSWay server, which is the web server we provide here, and then send both to the dashboard client, which can map the data to the template and show you the web page with the information from the OPSWay server. So we go now into the live part. We will therefore go on our next side. So we have here on dashboard configurator. That looks very simple. Is currently we create a new version of this, which then will be also online. So you can use this to create your own companion specification. So first of all, we need our information models from the companion specification uploading or integrated. In our case, we need the device integration and the machinery for the machinery stuff. We need the two models from the mining. They have a general mining information and then the specific for transportation. So we're uploading the files. You see the files are uploaded very fast. We can now look which part are integrated. What's the types we have here. We see also our haulage machine type is in the model, so it works. And then in the next step, we can go out and choose for which type we need to create our specific template. And here we search as to our machine transport specification and see here our haulage machine type. In the next step, now we can configure our template, define our header. The header is this here, here up, in the up. So we have here a name we can choose and the model. Here as name, we can here choose some values. That are the values from the companion specification for this type defined. So if we have here our mining equipment identification, we choose here our asset ID that want to show, and as model, we choose the model of the identification. Also, we can define some image configuration, can define stack, slice, and timeline. That's should enough for today. Sorry, that was misclicking. The starting point of each template are sections, so we can here add a section. We call it identification, like the other ones. And now I need to go to the cheat. So, back. Identification. And then we can go one step deeper, add a row. We can also give this row and our title. This is something we don't want to do today. Now we can say, okay, at first we want our manufacturer is shown, and then we also choose here in our mining equipment our manufacturer. This can be done with every thing. Now I think we choose here 3 points. The product instance URI, for example, as a second part, which is also always given the machinery, and then as third the serial number. And also we map this here with the serial number of the identification part. Here. So this describes the complete identification part we want to show from our specification. I think, say, those 3 are all important things. And that's enough for identification. So we create a new section. Now we want the current payload also given. This should be in the section parameter. We also add here a row. The text element can also be a variable. So we can say as label, we call it current payload. And here's, we don't want the identification, we want now the current payload, which is also moving. Select them from a parameter set. And because we want to show it a little bit also in a graphical way, we choose here our chart element. This is a Gauss graph. And choose here also the same value for the current payload. So in our small example, this should be enough. This can be also a lot of more information containing tables and lists. For example, if we have here placeholders in mind, also this can be covered. Now we download this file, and this is something, and can then upload this to our dashboard information. And now we're done for our part where we configure our dashboard. And if we go to our approach back, the configuration is done. And now we need to implement, start an OPSWA server, connect this OPSWA server to the dashboard. And this is the only thing you do to do as manufacturer, because of the template of the Companion Specification is done before by the Umati community. As gateways, this OPSWA MQTT gateway, we have here our dashboard OPSWA client. You can download this. We have different possibility to start it on different platforms, also as a container. Have here a small script that starts me my OPSWA server here, and also it starts here my dashboard client that reads the data and put it on the dashboard. Configuration here must be done in a JSON file. To implement our or configure our dashboard gateway, in our case, we enter here the URL of our OPSWA server, and also need here our MQTT gateway added. In our case, we want to connect to the develop part of the Umati dashboard with the port 443. Has my username and password. I think I need to change this afterwards, and also a client ID, which should be the same as the username. And this is also I have to do in our specification part. So only give here in the configuration the parameters of the OPSWA server and of the MQTT broker for the dashboard. You can save this. Look at our component Docker compose file, where we have here our OPSWA server started, and also the gateway, which will then connect to the OPCR to the Umati dashboard. So we start this thing. You see both parts start. The OPSWA server build his address space with information, load this and start the communication. And also the gateway is try to connect to the server and then publish this to our point. This works in 1 minute. Therefore, we start then our MQTT Explorer. This is a small tool where you can look at the OPS broker itself, and here then we see how in a huge seconds that our OPSWA servers get the data and then send this data here on the MQTT broker, and then this should also be seen on the dashboard. So now you see the client is on one. We see here he sends data to our truck, and this is the time we look at the Umati dashboard. We now search for trucks. We see here this truck is online. This looks very good. And now our truck is show the information, the parameters for our value, and also if the value is increased, we see here our gauge is changing. So if we want to start a second truck, we only need to download the dashboard client, change the configuration, restart the server and the gateway, and now can add the second track to our dashboard. Very easy. So that's from this part, from the live part, and I switch back here to the demonstration on my slides, where we show you the complete integration, start a server, and now I want to tell you something about how you can do this. It's very easy. Every Umati member can do this. Write an email to us for the info@umati.org. Then you get this credential for the MQTT broker, the password, the username. You can then download the gateway here via this link. Adjust the configuration, start the gateway, and this is then done. And you have access to the Umati dashboards. Can see if your server is implemented like the other ones. Prepare the same data, and can show, for example, on some fairs. What's the future development? We want to continue this. First is that we currently want to also integrate OPC PubSub communication. Therefore, we really define a topic structure, define how we want to get the data from the OPC PubSub from the publisher, and then this will be integrated. Also, our own MQTT structures and encoding should be replaced via the OPC PubSub. Also, the KPI calculation should be done in a dashboard. Of course, not all information and all KPI calculation are possible. Only via the OPC information data, the machine data, and this will be according to the machinery where some of the parameters are defined, and the ISA 400. Sorry. Next, also we want interaction, so we want the job monitoring for the machinery job management and the ISA 95 job control, and also a job management, so we can use the dashboard as a small prototype of an MES system to write jobs to an OPC server and then interact with them. And also the generation and the types template should be improved. For example, we want to make an online template generation, so this can be done online via some of the servers are sending that data, and you see the results of your modeling or generation in real time on the dashboard. And the second thing is that we say, okay, also the type system, we have a type system in OPC, so we want also sub templates which are based on types. So the identification, which is part of machinery, looks in every machine's name. And the integration in Companion Specification would be is not much more easier. And the last thing is that we also work in Factory and the project of Factory X, which is a German research project, and there we want to integrate the Umati dashboard with the EDC and the data spaces, so you can send OPC data via data spaces and the data space concept.